Okay, this is the fourth day of InterviewBit, and I feel very sad today because we didn't have a gaming stream yesterday because the coding stream took a lot of time. So that's why I want to do two parts from now on so that I won't be exhausted with a single long session. And the questions are gonna get tougher and tougher, so I better start very early. We have 12 hours left nearly and 500 point goal. Let's do it. We actually went through these yesterday. So space complexity. Let's just look at the last one and continue. Okay. A comes up with the following code. I less than n divisible, if n divisible by I, n is not a prime. Add 1 to I. While I less than square root of n, if n divisible by I, n is not a prime, add 1 to I. Which is faster? Obviously, the second one will be faster because this one is going n times. This one is going only square root of n times. Wait, am I wrong? No. The first one is going to take just a second. And in the inner loop, we're having j equal to 0, j less than I, and j plus plus. Not really sure. Not really sure what to do here. Okay, for the first time, the inner loop is gonna run for n times. Second time it's gonna run for n by 2 times. Third time it's gonna run n by 3, 4 times, and so on. And it's gonna run at the end only one time, right? One time. I think we already went through this once. I feel like we saw this once. Hmm. We definitely saw this once. Hmm. What should I see it? I just want the summation of these n plus n by 2 plus n by 4 plus so on till 1. Damn, I'm very bad with these summations. So annoying. Take a look at the discussions. Mathematics behind nested CP3. For those who didn't get it in the first go, they can understand like this. First of all, the outer loop. Look at the outer loop. I see it iterates from till I less than 1, yeah, or 0, yeah. Outer loop executes for the values for I equal to n by 2. Same thing. Oh, n by 2. Okay. 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 So the loop is gonna stop when n by 2 power k equal to 1. So it means n equal to 2 power k equal to log n. Okay, log n. Outer loop executes for log n times. Okay, the outer loop executes for log n times. What about the inner? The inner loop executes summation of all these things, right? Wait, what? I am very confused actually. The outer loop executes log n times. That's very clear. Hmm. 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 What if we just ignore the coefficient n times? We just need to evaluate the GP and complexities and please give an opinion on this method. I equal to n, t equal to n, I equal to n by 2, t equal to n by 2, so on. Yeah, so he is saying the outer loop is running for log n times, which was very clear. We forget about that. We just want the thing for inner loop. What do we do? What do we do for the inner loop? Okay, so this seems to be a formula for a summation of this GP. Okay, 1 minus a power. Oh, okay. Okay, it is a standard shit. Hmm. Anyway, I did understand a bit like how it went. So let's just go with the answer that we know already. All right. Yeah, one more 80 point question. Loop complexity. Oh God, these loop complexities are getting out of hand now. Okay, I equal to n by 2. Strangely, it starts from n by 2 this time. Um, just a second. Okay. Let's do it. Yeah, this. Oh crap! Did we? Crap! We did. We opened the question and goofed off somewhere. I starts from n by 2, I less than equal to n, and I plus plus. So it's basically big O of n. It doesn't matter if it starts from n by 2 or whatever the hell. So outer loop runs on big O of n complexity. What about the inner loop? Inner loop starts from 2 less than or equal to n and j equal to j times 2. Hmm. Okay, that's an interesting one. So the loop stops when the 2 gets multiplied with the 2 power k. When this 2 power k is equal to n. So 2 power k plus 1 equal to n, k plus 1 equal to log n. This is basically log n. So it's n log n. Let me check that. N, nope. N power 2, nope. N power 2 by log n. No, I guess it's n log n. It is. I should have done it before goofing off. Damn it, I lost so many points. Anyway, anyway. Um, how many points do we have right now? 125. Good, we're doing very good today, actually. Actually. Alright, we completed these three sections. I'm not sure whether we can do these things because it involves recursion and something else. Okay. Yeah. Recursion. I don't really want to do recursion right now. It's going to be so complex. Amortized complexity. What does amortized? What does it mean? Amortized. Gradually write off the initial cost. Reduce pay. Okay. Paying debt. Should I do it? It's 3 minutes. It's the toughest one, right? No, this is the toughest one. Let's do it. Let's not do recursion right now, but let's just do this one instead. Okay. We want the time complexity. There is an array involved. Okay. J equal to 0. I equal to 0. I less than n plus I. Okay. Hey, the solution is incorrect and it seems like you're stuck. Really? I didn't even submit the solution yet. Okay, the outer for loop seems to be doing an big O of n, seems to have a big O of n complexity. The inner loop, j less than, while j less than n and array of I less than array of j. Array of I. Element at index I is less than element in index j. Increment j. Does it depend on the values of array? See, it's an end, so it does kind of depend on the values of array. Let's take the worst case where I is n minus 1 and oh, wait a second, the j is always incrementing, so does it matter? No, I don't think it matters actually. It doesn't depend upon if the j becoming 0 for every for loop, like if the j equal to 0 is here inside the for loop instead of being outside, then it depends upon the array. Since it's inside the while loop, it's gonna keep implementing at some point, and you're gonna break this condition at some point for sure. Yeah, I don't think it depends on the array. So what's the answer then? If you don't consider this while loop, it's big O of n. So this option is ruled out, and log n and n times log n square. I'm not sure how these two come into picture. Absolutely. Let's look at discussions. Solution is very easy. What is it? Loop starts with I and j 0. 2. So if array j is not equal to array I, hence the loop will not run. Okay. I equal to 1, j equal to 0, the loop will run because j will run and j will become 1. I and j are 1, hence the loop will not run. It is j here. Oh, okay. I and j are 1 and the loop will not. Okay. And oh, okay. I get it. So the j is incrementing and becoming equal to I. In that case, this condition will fail. This condition will only pass if I is not equal to j. I get it now. Okay, that's a tricky one. So I'm gonna leave the recursion because the recursion is like where maths, array, binary search. I think it's way deep somewhere inside the levels. So I'm not gonna do this. Can try attempting, but I'm not gonna do it. I have 222 coins. I don't want to complete this entire thing in a one session because it's too much time. So I'm gonna stop at 1 hour mark. Basically, just doing two more questions. Yeah, we are done with level one. All right, programming. Yeah, we're done with level one. So I'm gonna skip to level two. Okay, what is the time complexity of the following code? And I get 50 points. Okay, let's do it. I equal to 0, I less than n, I plus plus. Same thing. Oh, we actually did this question right now, actually. It's we go up and okay. Easy 50, easy dub. Do you want to redirect to the programming page? Yes. We did this question, right? What if I click on it again? Oh, it's just done. Okay, that is done. I got access to level 2. Arrays or math? Let's start with arrays and go to math. I mean, I'm gonna do it in Python, so it actually doesn't matter unless they talk about introduction to pointers. Yeah, these are oh sorting algorithms. Okay, that's one fun thing. Although you're not going to use sorting algorithms at all, we're just going to use the sort functions. But knowing having the knowledge of sorting always helps, I guess. Yeah, let's look at one. It's going to be very easy if you use Python lists. It's going to be very easy. This section is going to be very easy if you use Python lists. Yeah, the audio is muted. You can't watch along with me. You have to play it on your own. You cannot watch along with me. Yeah. All right. That's about pointers. We almost reached like halfway, right? So I'm gonna stop the stream now and we'll continue with the night.